Okay, this next section is more about matrices. These are some other characteristics, things about matrices. First, we have a determinant. A determinant is a scalar number, so it's not a matrix. It's a scalar number that represents a square matrix. It has to be a square matrix. Now, the determinant of a 2 by 2 is fairly straightforward. If you look at a 2 by 2 matrix, and by the way, the symbol for determinant, notice these that look like absolute value signs. That means the determinant. If it's just straight lines, that means it's not the matrix, it's the determinant of the matrix. To find the determinant of a 2 by 2, you cross multiply and subtract. So you start, this is called the main diagonal here. This one right here is called the main diagonal. You start with that one. So you multiply there, A times D minus B times C. So A times D minus B times C. So that's the determinant of a 2 by 2. This one, these should have been looking like absolute value also. So this is another 2 by 2. Same thing, if I wrote it out, we start with the main diagonal. That's 1 times negative 1 minus the other diagonal, 2 times 3. So 1 times negative 1 is a negative 1 minus 6. So the determinant of this is a negative 7. So notice we just got a single scalar number. It's not a matrix for an answer. Now, 3 by 3 is a little more complicated. Basically, you're going to break it down into 3 2 by 2s. You start with this A right here. If you took that A, if I kind of overlooked it, that A is in the first column. So if I blocked out the first column, A is also in the first row. If I blocked out the first row, do you see that 2 by 2 that's left over? We're going to take A, that first number we had, so that A that we had right here, we're going to take that A times the determinant of that 2 by 2 that's left over. So that 2 by 2 would be E times I minus F times H. So here's the first one. We take that A times E times I minus F times H. Okay? Then we always put minus. It's always minus the second number. So it's minus B. Now, if we got rid of that column, this is hard for me to block off. But if I get rid of that top row again, now B is in the second column, so I need to get rid of that second column. I don't know how to block it off. If I get rid of that second column, you see those 4 that are left over? D, G, or D, F, G, I. We're going to take the determinant of that 2 by 2. So we take D times I minus F times G. So it's minus B minus this second one times the outside 4. D times I minus F times G. Now we move over to the third one. It's plus the third one, so plus C. Now if we block out those, so C is in the third column, so I block that off. It's still in the first row. Those 4, D, E, G, H, the left 4, we're going to do the determinant of those. So D times H minus E times G. That's the determinant of a 3 by 3. So if we were doing this one right here, we start with the 3 times, now we're going to look at these 4 right here. So that'll be 5 times 1 minus 0 times 4. So we took 3 times these lower 4, these right 4. 5 times 1 minus 0 times 4. Now minus, remember we always take minus the next one, minus 4. Now we're going to take the outside 4. So that'll be 3 times 1, that's our main diagonal, minus 0 times negative 1. That took care of the middle one. Now we move over to the one on the right, the negative 2. So a negative 2 times, now we're going to do the determinant of these left 4. So that is 3 times 4 minus 5 times negative 1. That's how you do the determinant of a 3 by 3. So then we just simplify those. Well, this is going to be 5 minus 0 is 5. 3 times 5 is 15. Here we have 3 minus 0 is 3. Negative 4 times 3 is a negative 12. And this last one, we have 12 minus a negative 6. That'll be 18. Negative, is that right? That's negative 5. I can't multiply. That'll be negative. That'll be 17. Negative 2 times 17 is minus 34. Now we combine those. 15 minus 12 is 3. 3 minus 34 is a negative 31. So that's the determinant of that 3 by 3. So that's how we do the determinant of a 3 by 3. Okay? The next thing is called elementary row operations. What we want to do is we're going to solve this using a matrix. The first thing you do is you create what's called an augmented matrix. An augmented matrix, we take the 4 coefficients, so 3, 4, 5, 3. So there's our 4 coefficients, 3, 4, 5, 3. Now we add a third column that has our constants, 1 and 9. That is our augmented matrix right there. That's called an augmented matrix. Augment just like means you add to something, so we added that onto there. Now, we're going to take this matrix. This is where we want to put it in row echelon form. That means we start here. This number is nice if this is a 1, but we really don't care. What we want to do is we want to go down first. We want to turn this number into a 0. Well, if I call this row 1 and this row 2, for our row 2, if we took, this is kind of goes back to what we were doing with systems. We want these two to match up so we can cancel this 5 out. Well, how about if I took 5 times row 1 plus a negative 3 times row 2? And that became my new row 2. So I'm going to leave the top row alone. We're not going to, it doesn't change, even though we're going to use it. It doesn't change. It stays 3, 4, 1. Now we're going to take 5 times row 1. So that'll be 15 plus a negative 3 row 2. So this is a positive 15 plus a negative 15 is 0. I'll go ahead and write that. So we took 5 times row 1. That'll be 15, 20, and 5. And negative 3 times row 2, that'll be a negative 15, a negative 9, and negative 27. We're adding those two together. So 15 and negative 15 is 0, 20, and a negative 9 is 11, and 5 and a negative 27 is a negative 22. So that's the matrix we have now. So we turned this one into a 0. Now we want to turn this one into a 0. We want a 0 right here. So if we took, again, think of cross multiplying like we did with our systems before. If I cross multiply, what if I take 11 times row 1? So here's my row 1 now and row 2. I'm going to take 11 times row 1 plus a negative 4 times row 2, and that's going to replace row 1. So if I wrote that out, 11 times row 1 would be 33, 44, 11. Negative 4 times row 2 would be 0, negative 44, and 88. We're going to add those together, and that's going to be our new row 1. So 33 and 0 is 33. 44 and a negative 44 is 0. 11 and 88 is 99. Now that was our new row 1. We left our row 2 the same as we had last time. We used it, but we didn't replace it. So now when we added those, we got 33 plus 0, or 33, 0, and 99. So there's our matrix now. Now we can stop there because now we can put our stuff back in. Remember, this first column was x. So that's like 33x. The second column was y plus 0y equals 99. This second equation, that's 0x. That's a negative 11y equals a negative 22. Well, now we can solve that like here. If 33x equals 99, then x equals 3. If a negative 11y equals negative 22, then y equals negative 2. Don't use this much anymore, but this was a lot of manipulation with the rows and stuff. Okay? The next thing, you can use a matrix to find an area of a triangle. What you do is, if I gave you the coordinates of 3 points of a triangle, so my coordinates, one of them is x1, y1, one of them is x2, y2, and another one is x3, y3. So that's the coordinates of the 3 vertices of a triangle. I'm going to make a matrix in them. So here's x1, y1, x2, y2, x3, y3. Now we're going to make a third column with all ones. So that's how we're going to set up that matrix. Now we're going to find the determinant of that matrix like we did up here before. Whatever we get for that number, we're going to multiply it by a half, and that works out to be the area. This is really handy on really large scale and really small scale things. Like if you're talking about a large area like a natural wildlife preserve or something. This is really handy because you can use the longitude and latitude for your points and then find the area. Also works really small things like if you're a chemist or something, you're dealing with molecules and stuff. You can use it to find the area of a molecule. So like here, it says here in the area of a region, from one point of a triangle region, so there's some point out here, doesn't matter where the point is at. Let's say I say it's right here. Now since that's our starting point, I'm just going to call that 0, 0. I can let it in, be anything I want. I like 0, 0. Another point is 4 miles east. Well, east is to the right, so let's go 1, 2, 3, 4 miles east and 5 miles north. North is up, so let's go 1, 2, 3, 4, 5. So there's another point. Well, we went 4, right 4, and up 5. That makes that the point 4, 5. See how that worked? 4 miles east, we went right 4. 5 miles north, we went 5. So if we let this be 0, 0, that's 4, 5. Now there's a third point, 5 miles east. So 1, 2, 3, 4, 5 miles east and 2 miles south. So that's right 5 and down 2. So here's a point here. So that would be right 5 and down 2. That's the point 5, negative 2. Now we want to know the area of this region. Well, let's do what we set up here. Let's take these 3 points and let's make a matrix. So we have 0, 0. We have 4, 5. And we have 5, negative 2. We just use those 3 points. Now our third column, we're going to put in all ones. So there's our matrix. We're going to find the determinant of that, and we're going to multiply it by a half. If you notice in the formula it says plus or minus a half, that's because if our determinant turns out to be negative, we multiply by a negative 1/2 because area is always positive. So that's all the plus or minus means. We just mean that means our answer is positive. Now, if we do that like we did up here before, remember we started with 0. Then we cross multiply and subtract. So if we start here, that means we're doing these lower right 4. So we take 5 times 1 is 5, minus 1 times a negative 2 is a negative 1. Then minus, we always took minus the second one, minus 0 times, now we do the outside 4. 4 times 1 is 4, minus 1 times 5 is 5. Then plus, now we do the last one, which is 1. Now we do the lower left 4. 4 times negative 2 is a negative 8, minus 5 times 5, 25. So we work that out. Well, this is going to be 6, but it's 0 times 6 is 0. This is going to be negative 1, but 0 times a negative 1 is 0. Works out nice when you use 0, 0, if you can. Here, negative 8 minus 25 is a negative 33. 1 times negative 33 is a negative 33. So now we're going to take 1/2. 1/2 times a negative 33. And this is where it comes in handy that we're going to use a negative 1/2 because now our final answer is 1/2 of 33 or 16.5 square miles. Okay? That's how you can find the area of a triangle. Now, the last thing is Kramer's rule. To be quite honest, I don't like Kramer's rule. I think it's a waste of time, but we're supposed to cover it. Kramer's rule says if you set up this system of, you have two equations with two variables here. Here's your coefficients, A and B, C and D, and your constants are R and S. We're going to make three determinants. One with just the coefficients. So A, B, C, D, A, B, C, D. That's our coefficients. The second one we call D sub X. This first column that was A and C, we're going to replace the X column with our constants, R and S. So you see how R and S took the place of A and C. Then we have dy. For dy, we go back to our first one. Now we replace the second column, our y column, with the constants, R and S. So we had one with the coefficients, A, B, C, D, one where we took that and replaced the first column with our constants, and then the other one where we took the second column, the y column, and replaced them with the constants. Now we're going to do the determinant of each one of these. So like this determinant is AD minus BC. But you're going to go through and find all three determinants. Let's do that down here. So here's our problem. So first we start with D. Remember, D is our four coefficients. So 2, -5, 3, -6. dx, we're going to just replace that first column, the x column, with our constants. So it's going to be 15, 36 in that first column, and still -5, -6 in the second column. Then for dy, we go back to the original. We leave the x column. I keep breaking off my lead. We leave the x column alone, 2, 3. Now we replace the y column with our constants, 15 and 36. Now we have three 2x2s. We're going to find the determinant. So this one we cross multiply and subtract. So a -12 minus a -15. So -12 plus 15 is 3. Here, 15 times a -6 is a -90, minus 5 times 36 is minus a -180. So -90 plus 180 is 90. Here, 2 times 36 is 72, minus 15 times 3 is 45. 72 minus 45 is 27. So we found those. Now we're going to use this last formula here. To find x, we take dx divided by d. So to find x, we take dx, which was 90, divided by d, which was 3, so x is 30. For y, we take dy divided by d. Well, dy was 27, divided by 3 is 9. There's our solution, 30 and 9. That's the second section here. Lots of different things about matrices.